Hello all, welcome to this data warehousing and data science course. Now, we will first look with the concepts, that is regarding the data mining, basic primitives. Then we will look in detail for each and every concept. So before we use the word data mining here, why people are looking for data mining? So there is a proverb, that is, necessity is going to be the mother of invention. In conventional model, most of the way was that in the first generation time, people used to store the data in files, then they migrated to databases. But at that time, database was giving a data which is stored in megabytes. But when it improved to gigabytes, terabytes, petabytes, at that time, there is no way that the relational database management is going to support that huge amount of content. So the proverb they brought, that is, necessity is going to be the mother of invention. So there is no opt that a traditional database management system is going to work efficiently and it is going to render the data as per the requirements. So people went with a new concept called as data warehouse. So when it is data warehouse, the concept took, it supports data in a structured way, first point. Second point, it went that it is going to support with megabits and terabits of data. It is going to support with megabits and terabits of data. And enough querying can be possible over the database. So this was where the conventional database got the solution. Second thing, in a database, we will just put some queries, we will get the data. Fine. In DataWare also we do the same, but the efficiency of the traditional linear search or binary search is going to fail to bring data from the database. So they went with advanced machine learning algorithms. They went with machine learning algorithms so that it gives enough insights towards the data, so that it is going to give enough insights over the data, and thereby people can mine data, people can get knowledge, or people can get patterns, people can get rules and constraints over that data. So first difference, in database, low volumes are going to take and store, but in data warehouse, vast volumes are going to be stored. That is first keyword. Second, when it is going to be with the data warehouse, an organization will have data which is going to be flooded across different locations, and those locations can be unified, integrated, and brought together. So this was the aim why data warehouse came into picture. Okay, fine. Now DataWare is taking megabits, terabits, petabits of data. Now to mine that knowledge from that vast volumes of data, then people went conventional algorithms like linear search and binary search may not be true. They went for machine learning algorithms. Okay, fine. How can I put machine learning algorithms over a database? it is possible with a technology called as data mining. It is possible with a technology called as data mining. So we have historic data, that is data which is stored for 10 years, 20 years, 30 years. From that data, we need to understand the past history. Then we need to forecast what is going to be done in the next. So forecasting is that we doesn't know what will happen tomorrow, but we can render a potential insights from the existing data. So there, data mining is going to come into picture, where it is going to tell that there it is going to discover the knowledge in databases. Again, why I'm going to use databases, because data warehouse, databases, there is no much difference at root level. At the implementation level, 100% they are different. What is 100% different? In database, we can store kilobytes, megabytes of data. But when we are going to work with databases, it's with the data warehouse, it is storing gigabits, petabits, ettabits of data. There, conventional way of SQL will not fit. So people are going for data warehouses. Of course, it is going to store the data in rows and columns only. Of course, it is going to store data in rows and columns only. So that is the reason why we have a structured approach, and that is possible in databases. So in the next, we will call interchangeable words, whether it can be a database or it is going to be data warehouse. Now coming to the one definition of a data mining was, it is going to have non-trivial, implicit, previously unknown and potential useful information or patterns from data in large databases. So now you should understand, when I'm going to use data warehouse, it is nothing but you should understand it is going to be a large database. So this was the intention, what we need to bring at this content. Second thing, there will be lot of vast volumes of data which we are going to call it as hidden data, historic data or previous data. From that, we need to get potential information and useful information and patterns. So what is a pattern? Let us see, you have some verbal aptitude part, 2, 4, 6 dash. So 2, 4, 6, next you can pretend value is 8. So how did you know 8? That means I got 2, I got 4, I got 6. So obviously I found the pattern between 2 to 4 difference is 2, between 4 to 6 different is 2, between 6 to 8 difference is 2. So that's the reason why I was able to predict after 8 the next pattern is 10. How did I know? It means I took the historic data. What is historic data? 2, 4, 6, 8. They are the historic data. What is the pattern? 2 plus 2 is 4. 4 plus 2 is 6. Every time 2, 2, 2, 2 you are going to increase. So that's the reason why I was able to make some potential insight. So how did I make that potential insight? I just took the previous data, I found a pattern, and then I predicted it. So that is where data mining is going to do. So how can I do it via data mining? You can do it via machine learning algorithms. What is machine learning algorithm? It can be association, it can be classification, it can be clustering. I will talk in detail with each and every word. Next word. What are the acronyms? What are the nicknames for data mining? So one of the most important and prominent nickname for data mining, we are going to call it as KDD, knowledge discovery in databases. It is called as knowledge discovery in databases, or we are going to call this one as business intelligence. So knowledge is available in a data which is in structured, which is stored in a database. From that, we need to get insight. So there we are going to use this word as a knowledge discovery in databases. Now, what is the drawback? In the earlier system was there is query retrieval which is problem, and that it is going to be highlighted with machine learnings, and statistical problems. Now here you are able to see the exact structure. Here you are able to see the exact structure of what was happening at this point of time. What is the relationship between a database, a data warehouse to a data mining. So this was the holistic architecture what you need to understand at this point of time. So the very first thing, we will be having a data warehouse which is integrated with multiple databases. Database brought from MySQL, database brought from NoSQL, database brought from SQL. All these has to be integrated, where we are going to call that phase as data integration. We are going to call that one as data integration. So whatever data integration happened, everything is going to be cleaned. Cleaned in sense, we should not have any empty cells. We should not have any type of empty cells, any type of missing values, because if we have such type of elements, we will not make any good predictions or assumptions, we will get zeros, etc. So these conventional databases are going to be an input to the data warehouse. So this is the stage one. The very first stage what we are going to talk was, we take databases from MySQL, we take databases from SQL, we take databases from NoSQL, we merge them, we integrate them, we clean them, so that there won't be any missing data, etc. That we are pumping it to the data warehouse. So data warehouse we are going to call in the earlier definition as a vast repository or a large database. So we didn't exclude the word database. We were telling that databases are there. From that databases we are putting together and bringing it to a data warehouse. So this is first thing. Next one, we are going to have selection from that as per our domain. We are going to have where we need to apply the task, where we need to apply the domain, where what type of content we are going to use. So that is what we are going to call it as task relevant data. So from the entire database, we are not going to make any insight. A partial database we are going to consider as per our requirement. Let us say an example, I want only blood group. So I don't want email address, I don't want mobile phone, etc. So I have a task, I need to understand what is the blood group. Therefore, only the item called as blood group will be taken up. So that is where we are going to say task relevant data. And from that task relevant data, we are going to bring up the data mining primitives. So what are data mining primitives? We have one, we call it as association algorithms with FP tree and a priori algorithm. Second one, we were talking about classification algorithms. In classification algorithms, we will talk about Bayesian, we will be talking about naive Bayesian, talking about linear regression, logistic regression, and followed by the decision trees. So these items will have an impact of bringing classification algorithms. Then we will be using unsupervised learning with clustering algorithms. So those algorithms such as k-means, k-medoids, hierarchical. So these, they are going to fall in unsupervised learning. I didn't talk about what is classified and supervised. I will do it in my next lecture. So we have some algorithms. So all those algorithms are applied over the specific task, and from that we are able to get the knowledge. From that we are able to get the patterns. So these patterns we are going to communicate to the domain end user, to whom we are doing this, to whom we are going to generate a report, for what we have identified the pattern. So that is where we are going to have a pattern, and finally we are going to give the recommendation. So that recommendation we are going to call here as a knowledge. So how did I get the knowledge? I got the knowledge from the databases. How did I got the knowledge from a database? I used data warehouse, I used data mining. So between data warehouse and data mining, I made lot of insights. I used statistics, I used mathematics, I used business domain, I used association, I used clustering, classification algorithms. Using all those, I'm going to get some patterns, and thereby I was able to give some valuable insights. So whether a cricket match is going to happen, whether this X country wins or not. So to give that question, I need to take the database of previous information about cricket, when these matches went on, when that pitch, the earlier matches between those two countries. So all that I have to mimic. I have to take up a task. I have to apply the data mine algorithms. Then I need to find the patterns where if the toss is won, how many number of chances for the first, if the toss is lost, how many number of chances for the next. So in this way, entire analysis has to be taken and then given to the knowledge. Yeah, we are going to win or we will be lose. In this way, we need to give a quick insight. So this is possible with a life cycle called as knowledge discovery in databases. With a life cycle called as knowledge discovery in databases. So this is what I was bringing to you here. First of all, we need to have a application domain. So assume that application domain was cricket, and I need to have prior knowledge on it. So prior knowledge, so what are the rules for cricket, how do they play, and what is the goal of the application? My goal of an application was, I just want to tell whether India is going to win over another country, yes or no. So for that, we are going to have a goal of an application. So first of all, I need to select the data. So how can I select the data? Means I have to have historic data. So I need to collect from the portals where cricket information is going to be maintained. So all the databases, I have to bring it into my laptop. I have to bring it into my application. So I am going to have a data set, and then one database will be stored in one model, another database will be stored in another model. For example, I write my name, first name and last name. You have a habit of writing your name with last name and first name, but if I'm putting together, it won't work. So I need to clean the data. I have to frame my own approach. So I'm going to pre-process the data. I'm going to clean the data. Then I was asking winning chances. So assume that there is a mobile number and email in that database. So a person win or not is not based on mobile phone and email. So definitely you can remove those data. So unwanted data has to be removed. They need to be transformed. They need to be normalized. So in this way, I'm reducing the size of my database. So later on, I'm going to apply the data mining primitives. I'm going to apply the data mining primitives. So what are data mining primitives? It is going to be linear regression. It will be logistic regression. It will be the classification algorithms with Bayesian, Nav Bayesian, decision tree, random forest, many more. And then I'm going to have association and clustering algorithms. So these all items, they are going to be part of the primitives of the data mining. And then I need to find a pattern. How I'm going to find the pattern? I will use formulas such as support, confidence, lift, precision, recall, accuracy, F measure, confusion matrix. I repeat it. 1. Minimum support, confidence, lift, precision, recall, F measure, confusion matrix. And this is how we will measure the accuracy of a classifier, and that's why I will be getting the pattern. I will be using statistics, I will be using mathematics, I will be using lot of linear algebra functions to get those patterns. And then I will draw bar charts, I will draw flow charts, so that the other person, he will be able to understand the things. So putting you the things in this model in a graphical user way will give you a good impression, good way of understanding to get the data, rather than writing the steps in a theoretical format in this way. So that is the difference of understanding of a human perception. We agreed. So putting the things in step by step, putting the things in graphical way, rather than writing the text in this one by one, they make a lot of difference. Therefore, their visualization, data visualization is going to play a major role. That is, we will generate histograms, we will generate bar charts, we will generate pie charts, so that you will be able to understand the patterns very clearly. And finally, whatever knowledge we expected, that knowledge we are able to communicate. So this is what we are going to call the different steps. That is what we call here as knowledge discovery in databases. So the next way of putting the things, this diagram, we will go in another way. So the basic way of putting the things, here we are going to say architecture of a data mining system. So this is what we are going to call here as a architecture of a data mining system. So we people, with our hands, we can type queries, etc. And that is possible only at the graphical user interface itself. We will do content creation, we will make usage of either data mining primitive, or we will use either data warehouses only with the graphical user interface. With the user interface only, we will be able to do the data mining or do the data warehouse content. Therefore, this is the first way of where users can interact with the content. Second thing, how people are going to understand the content. They are going to understand the content using the patterns. How is pattern generated? It is generated with support. It is generated with confidence. It is supported with, it is going to support with precision. It is going to support with recall. It is going to support with F measure. Then it is going to render the content in confusion matrix. So all these elements, we are going to say a pattern is going to develop. So patterns are developed with data mining. What is data mining? It is going to be an interdisciplinary field where we will use business domain, we will use mathematics, we will use statistics, we will use algorithms, we will use machine learning. All these elements are put together to form one approach called as data mining. Okay, then what is data science? So for the data science also we define the same. Yeah, we define the same definition for a data science and data mining. Then what is it differentiating? The key difference is at here. One, in data science, we work with structured data and unstructured data. That is the first core difference between data mining and data science. We work with structured data and unstructured data. That means we will be using NoSQL and we will be using SQL. Both of them are put together. There we will be rendering information. So that is where data science is taking up. But as far as data mining is going to concern, it is going to look up the things in relational database model system, that too in a structured format only. That too it is taking up rows and columns. So until rows and column approach is going to be brought, we cannot do the things for data mining. So that was the first difference. Second difference, we are going to have big data content. We will be using big data content. So in big data content, we will be using Pig, Hive, Hadoop framework for data which is to be in internet, which is going to be stored in clouds with gigabits, terabits, petabits, exabits. So vast volumes of data is there. Their big data is going to come into picture. At that time also data mining is there, but it won't give enough insights. Therefore, we will be looking there with big data, data mining, and machine learning algorithms put together. We call it as a data science. But here we are going to say we take up structured data, and in that structured data we are going to happen with data warehouse, and over that we are going to apply statistics and machine learning algorithms. There the data mining is going to fit. So this is what the difference, what you need to understand between data science and data mining. So coming to the original architecture of data mining, we do have graphical interface. We are going to find patterns with precision, recall, F measure, accuracy, confusion matrix, etc. Then we are going to derive that information. We are going to get the patterns, we are going to get the insights, etc. from the data warehouse. So data warehouse, it is going to have sources from multiple database. It can be from Unix operating system, it can be from Windows operating system, it can be a NoSQL, it can be MySQL, it can be SQL Server. So any type of data can be transformed, can be integrated, can be put together. So unwanted data is cleaned, missing values are filtered, we will be getting clear data. So that is where we are going to say a data warehouse is going to be brought. So from the data warehouse, it gives an input to the data mining. From the data mining, we will be using patterns and evaluation, and thereby again we are communicating it to the end users. So this is what we are going to call here as a holistic architecture for data mining. So this diagram will be a quick insight how data mining is going to be related to the content. So I just bring you the core definition here. The core definition was it is going to have multiple disciplines. It is going to have multiple disciplines. So those multiple disciplines, they can be with traditional databases. They can have statistics, having with machine learning, then pattern recognition, followed by working with neurons, where it is going to be the basic content with deep learning, machine learning, and artificial intelligence. So we have neural network technology, communicating the things with data visualization with bar charts, path charts, etc. And working on social media data, that is with text mining, etc. We call it as information retrieval. So working with Google, taking the data, communicating with Facebook, communicating the data on Instagram, working with YouTube's, and then surfing the things in Google. All those information, they are going to fall with the information retrieval, because we are surfing on internet, we are getting information from the internet, we are able to extract information from the internet. So that is where we are going to say this information retrieval is going to happen. And if we are going to work with pictures, audios, videos, etc., we will be calling it as image and signal processing. And finally, if we are working Google Maps, if we are able to work on maps, etc., then such type of databases we are going to call here as spatial data analytics. So holistically, data mining, it is with multiple disciplines as per the definition. We call it as database technology. We use mathematics and statistics, machine learning, then high-end CPUs like Core i3, Core i5, Core i7, high-end computing content, followed by pattern recognition with classification, association, and clustering, and deep learning, artificial intelligence, which is from the basic foundation of neural networks, and bar charts, scatter plots, etc., with data visualization, and surfing the things via internet using social media platforms such as Google, Facebook, etc. So this is what we call it as information retrieval, and doing the things, searching the things with audio, video, images, data, we call it as image and signal processing, and working with maps, the world maps, etc. So those items we are going to call here as spatial databases. So these all are going to be the quick insights towards data mining. So with this, we will just have a quick recap of what we will done today. So first of all, we were talking about the need of the data mining. The first need was it is from data, then to information, then it went to databases, then it came to data warehouse. Now trend, databases converted to big data, and now we are using data science, etc. So what will be the solution for a conventional database is going to fail? The solution was with data warehouse and data mining. What the things we can do? We can have patterns, we can have rules over it, we can give quick insights over the data. So what exactly a database is going to do? So what exactly a database is going to do means, here it is going to bring up the non-trivial content. It is going to mine up the unknown patterns, and that too it is going to work on vast databases, which we are going to call it as data warehouse. What are the pet names or other names or other acronyms for data mining? Yeah, people call it as data dredging, people call it as information harvesting, business intelligence, knowledge discovery in databases. All are called with the same definition for data mining. So this is the holistic architecture of data mining, where you can bring up a process called as knowledge discovery in databases. So we have different types of databases. All the databases has to be cleaned, missing data, etc., unwanted data has to be removed. They need to be merged together and put it in a structured form, put it in a more informative way, where we are going to call this element as a data warehouse. We will be finding a domain problem, to which domain we are going to work up this data warehouse. It case for a supply chain management, health, insurance. So what type of sector task we are going to do it? Thereby we are going to apply the data mining primitives, association, clustering, classification. All those algorithms are going to be part, and thereby we get accuracy, precision, recall, F measure, clusters. So all that information we are going to get as patterns. So from the unknown data, we will be getting some useful information, which one we are going to call it as knowledge. So this knowledge we are discovering in the database, where previously nobody knows. So data was there, from that we get useful information, we call here as a knowledge here. So this we are going to communicate to the business and user. So this is what we call here as a knowledge discovery in databases. So the most important thing, we will communicate with the tools like Veka, etc. Via the graphical user interface, we will be getting patterns. We will be supplying it to statistics and machine learning algorithms. We will be directly working on a data warehouse, and which it is going to be unified with multiple content. So finally, it is going to render up the patterns. So this is what the architecture of data mining was.